All right, greetings, YouTube. Beautiful Mind here. Let's see. So this will serve as the lecture for week 6, Wednesday, for applied statistics. Hope everyone is doing well. A few announcements for this group is that, let me see. One, be sure that we've completed the participation and honesty quiz via Moodle. That's important for submitting grades. It's going to be a part of our grades. It's not a heavy part, but it's important. So be sure to get that submitted. Let's see. I think there is an assessment on Moodle, so you want to go ahead and submit that as soon as possible. You get one attempt. It's timed. It's just a gauge to kind of see. It's just an assessment. It's also going to count as a quiz grade. It's not a heavy grade, but it will be part of the grade. Okay, that's on Moodle. And then the other thing is, once I load the homework for chapter 6, I think that'll be the remainder of the work for the rest of the quarter, right? So we have just outside of 2 weeks remaining, okay? So my intent is to load the assignments for the rest of the quarter, including the final exam, as soon as possible, and reduce the late penalty from 20% to 10%, okay? So I know that some students have like asked for extensions and extra credit. So me posting this stuff early is the extra credit. Posting the stuff early with unlimited attempts, and you can still get an A on all assignments, even old exams. It's a lot of work, you know, but with it being posted and you get an unlimited attempts, honestly, the only reason that you wouldn't get an A is that you just didn't want it. Like, you know what I mean? But I know it's a lot of work. Like, so that's why I kind of at least try to get up early and give you unlimited attempts at it. Okay. I'm available if you have questions or if you need support. I'm here just to encourage you, but you know, it's on you. You know what I mean? But again, I am here for support. So like if you have questions about the homework or something doesn't make sense or whatever it is, we're here, you know. So I'm here. I think the tutor is available. You have support. You just have to take advantage of it. We're not gonna like hound you too much. It's really on you. Okay, so today we just want to go continue chapter 6. We only have about 3 sections remaining. Okay, yeah, and chapter 6 is enough because this is more than what I've done with my students in the past. So today we'll look at section 6.2, confidence intervals for the average for sigma unknown. Okay, so say we don't know the population standard deviation. So you have to forgive me. I'm a low-key aspiring vegan. I'm not really vegan, but I aspire to be. So what happens, like basically the past couple of days, I've definitely had pizza both of those days. And so now I have all this mucus that I'm trying to get out of my body. That's the long and short of it all. Yeah, okay. So confidence intervals for the average for sigma unknown. So some objectives for this section are how to interpret the t-distribution and use the t-distribution table, and then how to construct and interpret confidence intervals for our population mean when this population standard deviation is not known. When the population standard deviation is unknown, the sample size is less than 30 and the random variable x is approximately normally distributed. It follows what's called a t-distribution. So the t-distribution is similar to the z-score, but it's adjusted for the unknown standard deviation. So to calculate the t-value, we would say x bar, which is the sample average minus the population average, divided by, I think that's the sample size divided by the square root of n. Let me see. I think that's the s. What's the difference between s and n? I got to think about what s is. Or maybe it's the sample standard deviation. I got to think about what this s is. I got to find that somewhere because I don't think that's a sample size anymore. me see. I gotta find that. We'll clear that up. We should be able to clear that up before we finish this section. So, let me. This is section 6.2. Let me check the book real quick. I'll be right back because my curiosity is piqued. Give me a moment. Okay, yeah. So I confirmed it. It's S is the sample standard deviation. Okay, so this is like the sigma is the population standard deviation, but we don't know it, so we can find the standard deviation of the sample. Okay, yeah, that's better. Just don't want to. We definitely got to minimize misinformation. Give me just another moment, Mucus. All right, we are back. Okay. So yeah, again to recap. So for the t-score is going to be the sample average minus the population average divided by the sample standard deviation divided by the square root of n. Critical values of t are denoted by t sub c. So those are critical values of t. The mean, median, and mode of the t distribution are equal to 0. The t distribution is bell-shaped and symmetric about the average. The total area under the t curve is 1. The tails of the t distribution are thicker than those of the standard normal distribution. The standard deviation of the t distribution varies with sample size but is greater than 1. The t distribution is a family of curves, each determined by a parameter called the degrees of freedom. The degrees of freedom are the number of free choices left after a sample statistic such as x bar is calculated. When we use the t distribution to estimate a population mean, the degrees of freedom are equal to 1 less than the sample size. Okay. So as the degrees of freedom increase, the t distribution approaches the normal distribution. For 30 or more degrees of freedom, the t distribution is close to the standard normal distribution. So I feel like that's straightforward. So this is analogous to the standard normal. The standard normal distribution it's just adjusted for when the population standard deviation is unknown. Okay, but it's similar. It's a similar discussion. Just it's tweaked a bit. So let's look at this example on finding critical values of t. Find the critical value t sub c for a 95% confidence level when the sample size is 15. Okay, let's see what's going on here. And let me go ahead and charge this. I'm not really using it like that. So because n is 15, the degrees of freedom is going to be n minus 1, which is 14. And then we use the table, right? There's a table in the back of the book. So using degrees of freedom is 14 and a 95% confidence level. We can find the critical value t sub c. So that's going to be the plus or minus on the curve, right? So that means that in the middle, 95% of the curve is going to be between these t values plus or minus, right? So we see the 95% confidence level. We see the critical t values with the plus or minus 2.145. And then if that's 95 in the center, that means that there's 2.5% on either side of the curve, right? And it's going to be like this. So again, it's similar to the standard normal, but it's not the exact same. So we can use technology to find the critical t value as well. Using the 84 plus, we need to know the area under the curve to the left of t, which is, there it is. Okay, to the left of the critical t value, right? So the 95 plus a 2.5 gives us the 97.5. Okay, so if we're on a 84 plus, initial t value, I don't know what the IMV stands for. I'm trying to think of what could it be. But the critical t value, right? So to the left is going to be 97.5%, and the degrees of freedom is going to be 14. So then it gives us the t value of 2.145. That's interesting. So for a t distribution, a curve with 14 degrees of freedom and 95% of the area under the curve lies between plus or minus 2.145. That's fun. Okay. So constructing a confidence interval for a population mean for a sigma unknown. Verify the sigma is not known and the sample is random and the population is normally distributed or n is greater than or equal to 30. Find the sample statistic in x bar and s. Okay. Find the sample statistics of n, x bar, and s. N is going to be the sample size. X bar is going to be the sample average, the average of the sample. S is going to be the standard deviation of the sample. So x minus x bar squared, sum of the squares. Yeah. The variance, right? Divided by n minus 1 and then take the square root of that answer. Where x identify the degrees of freedom, the level of confidence C, and the critical values of T. The degrees of freedom is going to be n minus 1. Then we use table 5 in the back. To find the margin of error is similar to when the mu is known, when the sigma is known, but instead of the critical z value is going to be the critical t value. And then instead of population standard deviation, it's going to be the sample standard deviation divided by square root of n. Okay, and then the rest kind of follows like before. So here we have an example on constructing a confidence interval. We randomly select 16 coffee shops and measure the temperature of the coffee sold at each. The sample average is 162 degrees Fahrenheit with a sample standard deviation of 10 degrees Fahrenheit. Construct a 95% confidence interval for the population average temperature of coffee sold. Assume that the temperatures are approximately normally distributed. Okay. So again, sigma is unknown. The sample is random. So n was 16. The average 162. You see it there? It says the sample average was 162. The sample standard deviation was 10. That was given as well. The sample standard deviation was 10 degrees Fahrenheit. It said it wanted 95, construct a 95% confidence interval. So the degrees of freedom is going to be n minus 1, which is 16 minus 1, which is 15. And then we use the table to find the critical t value. Okay, and it ends up being 2.131. Let's see. So then the margin of error is going to be the critical t value, basically that formula from before, and we plug in the values that we have, and we get 5.3. Then we have to do plus or minus, right? Let me see. So the margin of error. So it's going to be the x bar. All right, minus e and x bar plus e. So then the population average. Okay. So with the 95%, we could say that the average temperature of the coffee sold is between 156.7 and 167.3 when this experiment is done for a large number of times, right? If we repeat this a large number of times, we have this confidence level. We're saying that 95% of the samples, the average is going to be in this confidence level. Okay, when we repeat this experiment a large number of times. Okay, so I know it was a little fast, but the main thing is, like, you could follow the formula And then just fill in all the parts. The hardest part about this is really deciding on being clear about what's the proper formula to use. Once you're clear about the proper formula to use, then you find all the parts, you fill them in, and just kind of follow it step by step. Okay. So we randomly select. Say, let's do another one on constructing a confidence interval. We randomly select 36 cars of the same model that were sold at a car dealership and determine the number of days each car sat on the dealership lot before it was sold. The sample average is 9.75 days with a sample standard deviation of 2.39. Construct a 99% confidence interval for the population average number of days that a car model sits on the lot. Okay. Sigma's unknown. It says n was 36, which is greater than 30. So then we can use the t distribution. Using n equals 36, the average number of days was 9.75. The sample standard deviation was 2.39. We want a confidence level of 99%, and since n was 36, that means our degrees of freedom is going to be 35. So then the critical t value from the table is going to be 2.724. So then the margin of error is the critical t value times the sample standard deviation divided by the square root of n, and we get approximately 1.09. So then we say x bar plus or minus that 1.09. Okay, cool. At least it's not showing. Support. Oh wow, people are up. So I just got to email somebody from my support for college algebra. So there was a comment. Let me see. Man, people are here. Who was up? Loved it. Awesome sauce. Okay. But yeah. All right. So we're going to let that be. Okay. StatCrunch. So we don't have access to StatCrunch. So we're saying with 99% confidence, we consider the population average number of days the Carter model sits on the dealer is between 8.66 and 10.84. Like, this is interesting. Like, this is the kind of stuff I was actually doing in grad school. But grad school was weird. Like, I feel like being a minority, it really, like, it was just a really weird little time, because I'm like, this is the exact same thing that we were doing in grad school. I mean, and like, that's like the difference between like 6 figures, like this, like completion of that program. But it was this exact same stuff. Like, it was the exact same. But there was nobody there that was like me, like minority. So I was like alone in a lot of the classes, and I'm like, this stuff is not difficult, but it was just so much like this weird air, and like nobody was there for support. I would go to, like, if you go to the professors, they didn't want to help. I at least want to help. I know students don't typically ask for help for intimidation, but what you all don't realize is that outside of, like, in other classes, especially the higher up you go, that willingness to be available lessens. Like, I've definitely had my fair share of professors that just don't want to help. I know that energetically I can be a little intense. I think that's just the nature of mathematics, but I at least am willing to help. I'm not gonna like hound students to make y'all help me, but I mean, to make me help y'all. But I am willing to help. But it just kind of blows my mind, and it's like, it was so funny because when I was in grad school, like, I would ask a TA for support, and they didn't know what they were saying. Like, they were just reading whatever the professor gave them, but they could not like explain it at all. Like, they had no sense of what was going on. And so I was just like, it basically was like racism. Like, that's the long and short of it all. That's basically what it is, what it was. It was a little bit of that and a little bit of my like insecurities and like this air of it. I was like, it was just kind of a lot. And so it's not for the faint of heart, and you just have to kind of get in a good program, get in where you can fit in and keep it moving. But it was very doable. Like, it is very, very doable. And it makes a big difference, finishing that kind of stuff. But that's neither here nor there. It is what it is, and when I'm ready, I'll get back in there. But it just kind of excites me because I'm like, this is the exact same thing we were doing in grad school. I mean, like, verbatim. nearly. So it's just interesting. So then with this next slide, we want to decide, okay, so as going through these processes, when can we use a normal distribution or a t-distribution? So this is like a flow, right? So if we start in the upper left, it says, is the population normally distributed, or is n greater than or equal to 30? If it's a no, then we can't use the standard normal distribution, nor can we use a t-distribution. If it's a yes, then the next question is sigma known? Is the population standard deviation known? If the population standard, if sigma is known, then we follow section 6.1, and we can use the standard normal distribution with the margin of error using the z-score, the critical z values. If the population standard deviation is not known, then we have to use the t-distribution, where we have to use the critical t value instead of z value. That's section 6.2, and we have to use the n-1 degrees of freedom. So, okay, in this example, we want to decide if we can use a normal distribution or a t-distribution. We randomly select 25 newly constructed houses. Notice that's less than 30. The sample average construction cost is $181,000. So that's the sample average. That's X bar. And the population standard deviation, so that's a known sigma. So that means more than likely we should be able to use the normal distribution. Assuming construction costs are normally distributed, they also tell us that it's normally distributed there. That actually we needed that. Should you use the normal distribution, the t-distribution, or neither to construct a 95% confidence interval for the population mean? We would use the normal distribution because the sigma is known and it tells us that the distribution is normally distributed. So is the population normally distributed, or is n greater than or equal to 30? That's a yes, because the population is normally distributed. Note that even though n was 25, which is less than 30, we can still use either the standard normal or the t-distribution because the population is normally distributed. Is sigma known? Yes. And so we can use the standard normal distribution. Okay. So they weren't really asking us to solve that one. They just wanted us to decide which one can we use. Okay, so we have two sections remaining, so let's just do a quick recap. So we'll have section 6.3 and 6.4. I'll probably go ahead and get those loaded. I'll more than likely go ahead and load chapter 6, and I want to just go ahead and make that the last of the new material for the rest of the quarter. So then I think exam 3 has been up since like last week. Okay. Also, I intend to reduce the late penalties from 20% to 10%. So what that means is that on any assignment, exams, quizzes, homeworks, whatever you want, you can go back and you can boost the score at least to 90, right? So I know it's a lot of work, and my intent is to get the final exam loaded, and I want to give you time, but you got a limited attempts at all of these for a couple of weeks. And so the sooner we can get these in, the better, because the closer we get to that final deadline of that Saturday of May 16th, Pearson's going to go haywire, like everything goes haywire. It typically does. So my intent is to like go ahead and get this stuff loaded. I'm going to go ahead and do one more lecture today. And then before I walk away, I want to just go ahead and make sure that Pearson is up to date as much as possible. Also on Moodle, be sure that you do the assessment and the participation and honesty quiz. Okay, if you have not completed those, just let me know. If it's not working, just reach out and we'll make sure that it's available. Okay, on that note, we're going to end the session here, and from one beautiful mind to another, enjoy the rest of your day. Peace.